Okay, just want to talk for a second about what we mean by uncooperative vectors. A lot of these problems, you're going to be given an initial velocity and it's going to be set at an angle, generally from the x-axis. So like for this problem here, maybe we'll say that our initial velocity is equal to 100 meters per second. And let's just say that this is set at an angle of 30 degrees from the horizontal. The horizontal is generally always the x-axis in most of these problems. So the reason why this is called an uncooperative vector, by the way, this is a vector, in case we need to review that. They generally have a tip and a tail. And this shows us vector quantities as a graphic, right? So it tells us the direction that a force is being applied or that a velocity is occurring. And the length of the arrow generally indicates how big that force is or how large that velocity is. And the direction of the arrow is the direction that it's going, right? And so this one is called an uncooperative vector because it doesn't align with the x-axis or the y-axis. So if it was a cooperative vector, it would look like that, right? Or it would look like that, but it doesn't. It looks like this. It doesn't line up with the x or the y. So in order to figure out what's going on with these projectiles, what we must do is we must break this down into its x and y components, right? We must figure out how much of this vector is over motion, right? Or like x motion, and how much of it is y motion. Because if I made a motion like this and then like this, right, that would be the same motion as if I did this. The same displacement anyway, the same result. And because this vector is uncooperative, right, because this guy here is uncooperative, it doesn't line up with my x-axis or my y-axis, I need to break it down into its x and y components, and that's super easy. We can go through the trig, and I can explain the trig in a different video. But really simply, if I want to find the x component, that's just equal to the original velocity, whatever that is. In this case, it's 100 meters a second, right? But that's just equal to the original velocity times the cosine of the angle, right? And in your calculator, that's what you're going to type. You're going to type 100 cos 30, hit enter, and that's going to give you the answer. And then for the y, it's the same exact operation, except instead of using cosine, you're going to be using sine. Right, so just as if you want to pause the video now and do it and just see if you get the same answers I get. So again, if I'm going to be doing the x portion, so whatever this is, the x velocity initial x like that, that x portion is going to be equal to the initial velocity of 100 meters per second multiplied by the cosine of 30. So in your calculator, you're literally going to do cos 30, and that's equal to 86.6. So we'll just round that to 87 meters per second. Right, and that means that my initial velocity in the x direction is equal to 87 meters a second. Generally, that means that the projectile is going to be traveling to the right at 87 meters a second constantly throughout the entire flight. The next portion here is the y velocity, and we'll call that velocity initial y, and that's equal to, again, my velocity initial of 100 meters per second multiplied by the sine of 30, and again, you're just going to plug that in your calculator, 100 sine 30, and that's going to give you 50 meters per second. All right, so hopefully that was helpful. I try to keep these videos super short. If you have any questions, you can always feel free to email me, tsmoka@mckeychs.org. Great. Have fun, and may the force be with you.